Right. So we are looking at section 4.5 in this video. And so this section is kind of putting together everything that we've talked about in chapter 4. So we've learned how to get the derivative and set it equal to 0, find the critical values, and figure out where the function is increasing and decreasing. We've learned to get the second derivative and find where the function is concave up or down. We can find the asymptotes. And so if we put all this together, of course, we can find the x and y-intercepts. And if we put all this together, we can sketch a pretty accurate version of the graph. So let's start. We have a basic cubic function here. Let's start by taking the derivative. So we have 3x squared plus 12x plus 9. We're going to set it equal to 0. Let's factor out a 3. And we'll divide both sides by 3, so I'll get rid of that. And then we'll factor this. So we get x plus 3 and x plus 1. And so the critical values are -3 and -1. And so like we learned in an earlier video, we'll put these on a number line. And I did explain this before. We'll kind of briefly explain it again. You can plug in points that are in the intervals. So not -3, not -1, but numbers that are between each of these intervals. See where the first derivative is positive or negative. But when you have this one that's a quadratic like that, this is a leading coefficient that's positive. So it's going to be the U-shaped parabola. And so that tells us that it's going to be positive here, negative here, and positive here. So you don't have to waste time plugging in values if you can kind of get around that. Now we're going to take the second derivative. So the second derivative is 6x plus 12. We set it equal to 0. And we get that x equals -2. And same thing, we're going to put it on the number line and test the points, or we can recognize this as a linear function and positive slope. So it's going to go up from left to right like that. So we're going to be negative here, positive here. All right, and that's the basics that we need. On the web-assigned homework, as far as choosing the graphs, it's multiple choice. Now, they make you do all this stuff because you have to pick out where the intervals are that it's increasing and concave up and all that other stuff. So you can't just graph this on your calculator and choose the right graph. That doesn't work. It'll get you the right graph, but it doesn't work for all the other parts that you have to do. So you do need to know how to do this, even if the graph is not necessarily you don't necessarily need all this stuff to do the graph. But as far as what we need to choose the graph, if we are going to do it by hand, this is pretty much all we need, almost. We're going to do a little bit extra just so we can be extra accurate. And one thing we're going to look at, one other thing, is the limits as x goes to infinity. And this is actually more important when you look at rational functions or exponential functions, because we can pretty much get this if we're increasing to, well, from -infinity to -3, we're increasing, then we're coming up like this that whole time. And so obviously the function is going to go down to -infinity as the limit as x gets to -infinity. But we'll still do this just so we can talk about it. Now, when x goes to infinity or -infinity of a polynomial, we don't need to worry about the lower exponents. We really only need to worry about the highest exponent. And so this function, as we move out to infinity, or you think of it as we're zooming out and not have a zoom in just in the area around the origin, this graph will look like x cubed. And so x cubed looks about like that. And so the limit as x goes to positive infinity is positive infinity, and the limit as x goes to -infinity is -infinity. All right, and then the other thing we could look at are the intercepts. And so for the x-intercept, we're going to set the original function equal to 0 and solve for x. We can factor out an x, and we have x squared plus 6x plus 9. We'll factor that out, and that factors to x plus 3 squared. And so we have x equals 0, x equals -3. And then y-intercept, plug in 0 for x, and then we just get y-intercept is 0, 0. And of course, I wrote an ordered pair here. These are ordered pairs also, 0, 0, and -3, 0. All right, so now we have everything we need, but one thing I find is helpful in doing these is to kind of make a table that puts, especially the first and second derivative information. We want to kind of put all that together because things change at different points for these two things. And so we're just going to put it all together. So we have our critical values, -3, -1, and 2. So let's put those on here. And we're going to do it like this. And we're going to have a couple of 3 rows here all together. And this first row is going to be looking at y prime. The second row is going to be looking at y double prime. And then the third row is going to be looking at the shape of the curve. And so we see that first derivative, we are increasing up until -3. Between -3 and -1, we are decreasing. And then after -1, we are increasing, or positive and negative, however you want to think about it. So we have positive, negative, negative, positive. So the spaces here are just the area for the intervals. So -3 to -2, -2 to -1, -1 to infinity. All right, so then for the second derivative, we are decreasing, or sorry, not decreasing, but we're negative before -2. We are positive after -2. All right, so now this puts all this together. And now we can talk about the shape of the graph. So before -3, the graph is increasing and concave down. So increasing and concave down looks like that. Between -3 and -2, we are decreasing and concave down. It looks like that. Then we are going to be decreasing and concave up. That looks like that. And then after -1, we are going to be increasing and concave up. So that looks like that. All right, then the last thing to do is let's figure out what the y values for each of these points, just so we can plot those, and then it's just a matter of connecting the points. So plug in -3 to the original function, and the y is 0. Plug in -2, and the y is -2. Plug in -1, and the y is -4. And then, of course, we have the intercepts. Both intercepts go through the origin. So now we'll just draw our x and y axes, and we can plot these. Let me spread that out a little bit more. We can plot these points on here. So we have -3, 0, and let's go down the y axis. We have -2, 2. We have -1, -4. And then we have 0, 0. So those are the main points that we need to talk about. So before -3, we are increasing and concave up. So let's just draw that shape like that. Then we're going to be decreasing and concave down. We're going to be decreasing and concave up. And then we're going to be increasing and concave up. And we're going to go right through the origin. It doesn't change at the origin, but that's just the y-intercept. So we kind of want to hit that one accurately. All right, so that's what the graph looks like, and that's what we're going to be doing with the other examples. And they may or may not be any more complicated, but I think if you get the process down, do first derivative, second derivative, find the limits, find the intercepts, If this helps, you can make this table. It helps me. I feel like that helps a lot. So, but you don't have to do that if you can kind of figure it out without that. That part's not necessary, but I do think it helps. And then you just plot the points that we find, and then you're connecting them based on shapes. All right, so we'll do another video for another example.